Okay, well, thank you everyone for joining our seminar series today. Just as a reminder that this session is being recorded, as you can see here with the rules that are listed. And so at this point, Yihua, I'd like to ask you to take over the screen sharing, if you will, and then I can give the introduction for you.
So,
okay, excellent. Yes, we can see your screen.
It's working? Yeah.
Yes, it's working.
Okay, yeah, okay,
yes,
great.
That looks great. Okay, so with that, we'll jump in here. So thank you again, everyone, for joining. I'd like to give the intro for Yihua Zheng. And Yihua received her PhD in 2001 from the University of New Hampshire on field line currents in the auroral zone using sounding rocket measurements. And she's a space weather scientist and forecaster who has been involved in providing space weather services to NASA robotic missions for over 10 years. And she studies the myriad of ways that space weather can manifest itself in near-Earth space. Yihua is the lead at the CCMC, the Community Coordinated Modeling Center, for the Magnetosphere models and for coupling space environment models with engineering impacts. And she has been involved in many community-wide multi-purpose model validation efforts. So with that, thank you again, Yihua, and feel free to take it away.
Okay, great. Thank you, Jason. Thank you, the seminar team, for inviting me to speak for CCMC, which is the Community Coordinated Modeling Center. So, but for today, I'm going to concentrate on the space weather capabilities and the resources. So for my talk, the outline is as follows. First, I will just do a introduction of CCMC, general CCMC functions. Then I will show highlights of space weather capabilities and the resources, like tools and the community-wide opportunities from CCMC. So, for example, here I listed a number of them. ISWA is an integrated space weather analysis system, and DONKI is a really database of space weather events, which I will show later. So we have a number of animals here. And we have a stereo CAT and SWPC CAT, that's from NOAA SWPC, that's for CME analysis tools. And then we have a community-wide space weather scoreboards, like for CME and FLARE, SEP, and also the future upcoming ones. Then we have a CAMEL, that's really a validation tool, which I will show you later. And then I will discuss about our community-wide space weather multi-purpose model validation efforts. And then towards the end, I will also show, over the years, we have done the space weather training for the forecaster, high schoolers, college, and other professionals. So some of the lectures may be useful for students and also even professors teaching space weather related stuff. So let me see if this seems. Oh, okay. I was worried that won't advance. So the for people who don't know, the CCMC was established in 2000 as a multi-agency investment in the U.S. space weather program. So one goal is really facilitate space weather research and model development. The other is to develop and deployment of new operational space weather capabilities. So it's really the capability coming from the community, but also serves as a community resource tool. It's a long-term and flexible solution to the research to operation, operation to research solution. And it really has a broad partnership throughout the entire community, including international partners. And I'd like to say a little bit things about the recent changes to CCMC. So recently we have CCMC got enhanced by 4 to 5 computer scientists by recruiting more to strengthening our run request, the traditional primary functions, run request services and other things. And also a new thing is establishment of Moon to Mars office. So before, from 2010 to 2020 August, it's a part of the CCMC, the space weather team. Now it's a separate entity, but has a close collaboration with CCMC. So it's led by Jadi Cladoviga, and it's a 8-person team as far as I know, but it works very closely with CCMC. So it's like a parent-child or maybe independent child relationship. So this is the primary reason for that is to support NASA's human exploration program, for example, the Artemis, and directly we work with Johnson Space Center, the Space Radiation Analysis Group, that's SHRAG. So this diagram shows the pipeline. Also, you can see the kind of working relationship. So for M2M office, they mostly use what the system built by CCMC and test out in real time, supporting the space weather needs. And also work with NOAA SWPC. So currently we are have been exploring using Amazon Web Services, so shared like cloud environment for like this pipeline, like a smooth working, like the passing the, if the model is ready to pass into the like to M2M and also Space Weather Prediction Center for the operational needs. So this is kind of a new change. And also the I'd like to mention CCMC's core principles, and the unique feature is that we have scientists and computer scientists and also computer system engineers work together, and most importantly, it has a trust relationship with model developers and the community. So we have the full respect for expertise and the intellectual property of model owners. And it's also customer-driven, very agile and flexible. So we can quickly respond to NASA's needs and to the community needs. And we also lead community-wide project campaigns to enable support and facilitate various efforts. So this is CCMC functions, the 6 major ones. We host like a number of many space weather, space science models. We provide simulation services through ground request. And we also develop visualization, dissemination tools, and also do the model evaluation assessment, that including the traditional ones, the event-based historical ones, and the real-time forecasting, real-time validation. And we, of course, support the NASA missions. It's also a major part of the CCMC function, is including, you know, the conception phase, like the conception and the mission development phase, and up to mission operational phase once it's flying space. So we also provide that, especially in our M2M office. Then we also build a number of data archives for research and space weather purposes. So this shows the number of, you know, the models hosted at the CCMC. So really it's 100 models or plus throughout the Earth domain, like space weather domain. And some of them are different kind of capabilities. Some are very complex first principle based model, and others empirical model. There's also model chains across the whole domain, and different capabilities. And so this is just an example of among 100, more or less 100 or 100 plus models, 20 of them are running in real time. So providing the forecasting or real-time capabilities. Here I'm showing one example, NARIS. For most of you maybe not familiar, this is really a space weather application model. It's for aviation safety. It has been running in real time since September 2020. Now the round request capabilities, NARIS is being worked on. And because of the user needs, like to really address the future commercial crew program like SpaceX, other space companies when they launch human into space. So this is also support their functions or hardware, whether there will be any space weather effects from the solar energetic particles and so on. Because of that, so NARIS has been through upgrade. So this the round request version will be called NARIS 3.0. So this is a kind of an example showing because of the user needs and the kind of feedback to the model developers for further modification and capability enhancement. So from now on, I'm going to concentrate on the highlights of space weather. I mean, a lot of our tools really is multi-purpose, but mostly space weather related. So this one is called the integrated space weather analysis system. Is really probably many of you heard about it. It's a web-based and user configurable, available worldwide. Is really one-stop shop for state-of-the-art information. So not only we have results from the real-time models, but also the data streams, you know, from a NASA satellite, from NOAA, and any data stream we can get our hands on. So this also like to thank the whole, not only modeling community and also the data providers for such a capability. And this one is, you know, this system I will demo a little bit later. It can be used for space weather monitoring and also for research, education, and for anomaly resolution, because we archive this. So these are a lot of this information we archived since 2010. So really from, you know, beginning, very early stage of solar cycle 24, and now we are currently in solar cycle 25 since December 2019. So that I'm showing you, this is really the product from that ISWA system. And this is a recent 9 May 2021 CME, and resulted in the largest geomagnetic storm since May 2019. And the KP real-time KP reached 7. And you can see here, it's the source region. So it's the images, EUV image from ISDO satellite. This is a chronograph from stereo A. You see the CME coming out. And this is our modeling results from WSN-LIU cone model. So really, once we see this happening, the Moon to Mars office analyze the CME, send it to the model, predict which location or asset will be impacted by the CME. And this is the in situ data from Discover. So you can see the arrival of CME on May 12th. You see the shock and the coherent structure of the CME itself. So then we have the space weather modeling framework showing the dynamic evolution of Earth's magnetosphere in response to this CME. So get really, they said magnetopause get really compressed in and close to the geosynchronous orbit. This white circle is a geosynchronous orbit. So this just demonstrates the system really can trace the ISWA system from the source all the way to the Earth. So during the Helio 2050, a lot of the whole community going after this system approach, studying, you know, the event or studying the heliophysics. So this is a really nice tool, and also to look at the chain of the event and also put everything in the global perspective, what maybe help students to understand things better. So here you can explore on your own. Is there a number of layouts? We can compose a layout for special different purposes. And for the first one, I did it for the Cape Canaveral launch at the KSC Kennedy Space Center for their launch, like a launch relevant products. Then this second one is for the wiki. That's a whole heliosphere planetary interaction campaign. for the first layout is the solar helio products. The second layout is for the geospace. And if you go to this website, and there will be a number of layouts used by our, throughout the years by the space weather forecasting team. And next, I want to show you DONKI. It's a database of notifications, knowledge, and information. So while the forecasters monitor the space weather, so we don't want all the effort to be wasted. So we captured, archive it into a catalog of space weather phenomena. And what's more is like we put linkage, like you know how the CME connect to the geomagnetic storm, CME shock, and the storm, and so on, all high-speed solar wind stream, and to the geomagnetic storm. So you have this intelligent linkage. So this is not only good for the space weather purposes monitoring, and also very good for event studies, for statistical analysis, and for anomaly resolution. So here, if you go to I provide a link down there. And if you go there, you can see the system. So this is like here you will see that you can search space weather activities, and there's different space weather activities. We have solar flares, solar energetic particles. All of these is like we are more or less threshold based. So it's exceeding certain level, we categorize it as an event. Then we have coronal mass ejections and the interplanetary shock and the magnetic pulse crossing that mostly based on the space weather modeling framework predictions. And geomagnetic storm, and that's based, a lot of them based on data. Only the magnetic pulse crossing, that's the modeling based on the model result. And radiation bound enhancement from GOES, and based on the GOES measurement, and the high-speed solar wind stream, and the WSA-LIU cone modeling result. So here you have the start date and end date, then you do search, and the system is very powerful. So you can see here that for the month of May 2013, you put the solar energetic particle here, and then you have a number of the events come up. So some of them Earth, the ICP event at Earth, like based on GOES, and this is the ICP event detected at stereo B. So it's different. So even though the Earth didn't have ICP event, but the stereo B experienced that. And then what I did is for this recent geomagnetic storm. So what I put is 2018 January. So you can see all the geomagnetic storm. This is a KP based. If the KP exceeding 6, so we categorize that the event. So you can see quickly, we also not only have the event time and so on, we also have a direct link like events, like whether it's a CME, the driver, the CME, or high-speed solar wind stream. The HSS is a high-speed solar wind stream. So you can see quickly that this recent CME, the first geomagnetic storm in solar cycle 25, it's the first one since August 2018. So that's a major storm caused by CME. All the things in between actually is due to a high-speed solar wind stream. So it's a really powerful tool. So I recommend people explore it. And next, this stereo CAT is developed by us, and it's actually started by Antti Pokkanen. This is really using triangulation to measure the CME kinematic properties like speed, direction, the angular width. So then after we got the parameters, then we send it to the CME model, the WSA cone-LIU model, cone LIU cone model to predict the CME. And then we also, this is the SWPC CAT, there's a NOAA SWPC CAT for CME, and another CME analysis too, a little bit more sophisticated. But initially, it's a Unix-based. You type, Unix command. So CCMC working with computer software, computer scientists, interns. So we have turned this into a web-based. It's become easier to use. And then next, I would want to talk about the scoreboard. So what the scoreboard really means is the real-time evaluation of model performance. So we collect forecast before event is observed. And when they allow, this way we can allow a consistent real-time comparison of various operational or research models, research forecasts. So it's a little bit different from the non-real-time model assessment. So this has to be done before, before the event. So I'm showing you this. Our first scoreboard is a CME arrival time scoreboard. And this has been into existence since 2013. So this is the longest existing scoreboard. So you can see for this major event in September of 2017, and there are a lot of participation from a whole community of different models. Some of them are just MHD, WSA, AMNH-LIU, cone model MHD. Some are empirical based, and some also with the WSA AMNH-LIU cone, because each group doing the gather CME parameter different, even with same model. If you have a different input parameter, so your forecasting result also different. So we can see this all in one location, so you can compare, readily compare them. And all these columns are sortable, so you can click them to it's sort according for different criteria, different columns. Even though they may look plain, but they are, there's hidden functions, capabilities. And again, this is for the recent one, the 9th May 2021 CME. So you can also see we have the CME, the tag ID, and the actual shock arrival time. Then there is also description of what caused it, the solar driver, the source. So this is like due to a filament eruption right in the middle, the center of the SDO, so Earth-facing solar disk. And next, I want to talk about the flare scoreboard. So because of different kind of different phenomena, and the model, the flavor is different. So for flares, it's more about a probability. Most of them is probability driven, and you can predict flare for one particular active region. You can also predict the flare occurrence of the whole disk. So this is starting, it's led by Sophie Murray, and it's a really an international group. It has, you can see a lot of models here. So, and also they have, the models have prediction for different class, different magnitude of flares, like C for common, M is for moderate, X is for extreme. So you can also see, like even for one model, they have a prediction for different class of flares. Then all of them can be put in one graph. But yeah, it's busy. Then you have to really look at it. But the layout or the design of this, we can just talk on and off. If you want to isolate, say compare NA2 or NA3, you can do that to avoid, overwhelming dots and triangles and so on. So you can have a cleaner comparison of the model of your interest. So this is what kind of layout is. They give you a solar disk and with active regions and the probability for C class, M class, X class, and for individual active regions, or the full disk. Again, that's what it looks like. And then recently, starting 2016, so this later scoreboard is built upon experience with previous scoreboard. So, but you can see, say at the CME arrival, you have a kind of definitive time. But flare, you go for probability. For SEP, I will show you later on. You have a intensity or duration. So you have a number of parameters of your interest. So each phenomena, the design has to be different. So it has to be tailored to, specific applications. So SEP scoreboard is for the solar energetic particles because it's really a concern for astronaut safety, for spacehead hardware, the type of space radiation. And it's led by Bureau, so it's also and the UK Met Office and GSFC is again a big community effort. So the point of doing scoreboard is to engage the entire community to forecast a certain event. So this is these are the list of models in the community. So they have different flavors. For SEP prediction, there is a continuous probabilistic ones. There is also not really near real time because they are complex, but they have a kind of event-based kind of table of extreme event. So you can have a sense of it. And also some of them are solar event triggered. Say you have a flare, then you start to do the forecast and so on and so forth. And this one is like the Hesperia and the release is built based on the electron to predict proton because electrons are lighter, faster. So you use the electron signature predict the protons or heavy ions. So it's a variety of models here. And also, I'd like to mention the CCMC, the close collaboration with Johnson Space Center, the SHRAG group for astronaut safety. So the ISWAT project is the integrated SEP prediction project. So it started in 2018, and the models chosen by SHRAG is based on these criteria. Like the requirement kind of run in real time. Is the input data available in real time on some degree of documented performance? So like there are some previous validation results. So this all kind of to meet the needs of the human missions beyond LEO in 2022, and also the Moon to Mars office also the primary functions to use these SEP models to help out with the SHRAG's needs. So this is the what scoreboard look like. There is also other display, but here I'm just showing the intensity forecast for the. I mean, the solar cycle 25 as a start actually quite strong. So I showed you the May 9th CME had a geomagnetic storm. So this is there's a CME of the West Limb, and has a very nice magnetic connectivity with Earth in terms of radiation impact, the SEP. So May 28th CME result in the ICP event, even though it's tiny. I mean, it's not so strong, but exceed 10 PFU for the greater than 10 MeV proton flux. So it is an event. So we have the like a performance from number of models here in terms of intensity. This is also called heat map. So the design of these is really a close collaboration between CCMC and SHRAG, like based on their needs. They want to see this colored table so they can have a quick glance of what's going on, and also they want to see the temporal evolution, the maximum intensity, like how long this event will last, and so forth. So that it's really like work with users or super users to design the products. And this May 28th CME, I mean, we can see the May this year already kind of active for the solar cycle 25. So another upcoming one is I'm leading this. Is the near Earth internal charging environment scoreboard. So is this the starting? So we have initial quantities for display. Really, is we try to, from the science, talk to the users, so address the user needs. So we have like here, the kind of display, the quantities is a flux, and what matters to internal charging really is a cumulative effect. So we look at 24-hour or 48-hour kind of fluence at the time cumulative effect during certain time interval. And then we put it in the engineering model to examine what the charging electric field. So we have a, and also charging current, whether it will affect your hardware. So next, I want to mention our CAMEL tool. It's really a comprehensive assessment of models and the event based on library tools. So this is like it's interactive web interface for display and analysis of evaluation. So this one not only can do the validation like for real time and also for event based, and has a database with API. So you can also, from this system, it's being worked on, you can download the time series, like download data and download the modeling results. And also we have a library of metrics and tailored to different specific studies. And all these, the behind the scenes is using the space-based, the metadata registry. We have a registry of model and a registry of data observations for the validation. And what's interesting, more interesting, eventually we want to do that for, say, for single event for different models, and also for multiple events, say one same model, how they perform over multiple events, like over a number of CMEs, over a number of high-speed surveillance streams, or over quiet time. So you can also do the kind of validation in the statistical sense. And next, I want to just show CCMC's involvement in the recent the community-wide space weather and multi-purpose model validation efforts. So this started with, of course, it's been doing the model validation through different campaigns before, but this is more geared towards the space weather capability, like how to track a model's performance over a long period of time. So in April 2017, had an international forum for space weather capability assessment and continuing work of that result in 26 publications from the forum teams. And also it's become a special collection on Space Weather Journal. So the major topic is to define the metrics that's not only useful for science, for scientists, for environment, but also useful for engineers and benchmarking the model performance. So that's the main goal. And here I want to show you the one example of that. So for the near Earth space radiation and plasma environment, so like from radiation belts, from solar energetic particles within the near Earth region, and can result in different impact on the hardware and on human. So we have started to define this space environment quantities, so-called EZQs, to connect the science and with engineering. Like it can be easily, these quantities should be easily translatable to the users, say to the NASA engineers, to the operational staff, so they know from that how like what kind of a sense of the hardware problems. So we have started with that. I don't have time to dwell on this. So then coming after that is the International Space Weather Action Team initiative. So this is even broader community, and it's under COSPAR. And really has, you can see, has a number of clusters, and also within each cluster there are a lot of teams. So if you go to just Google it, you will. And so this is actually not only have each region, but what we want to emphasize is the connection between all these regions and the connection between different teams, because everything more or less the sign is the driver. So if you want to understand more or predict better of your, say, ionosphere, thermosphere, or near Earth radiation, you need to go back to the sun and to see how to improve forecasting capability, longer lead time, and so on and so forth. So this initiative also encourage kind of a system approach. So from here we have different cluster, different regions. We also encourage cross-cluster working relationship, and together tackle the space weather forecasting problems. And also, mostly importantly, this initiative encourage younger people, like early career, to lead some team effort. I mean, it's not just the space weather, it's also, how to do the forecasting. So there's also space science for people who don't care too much of space weather. And also everything kind of bonded together by the impact. So I encourage people to take a look and pick a team to participate in. So I'd also like to mention the Space Weather Bootcamp training lectures. So since 2012 we have trained because the space weather team was very small, and so we also like to train next generation, like high schoolers, college students, to start getting involved in the space weather and space weather forecasting. So we started the training from 2012, started 2011, but start 2012 is more formal. So I want to say now we kind of stopped, it's 2012 to 2019, but a lot of lectures are still online. So this also from the side and going to different regions, also the impact on satellite being there's lectures. So some people may find it's useful. And I want to say 2012, the Michelangelo Romano used to be our college intern, one of the college interns, the first 3 interns to do the space weather forecasting. Now he works at Moon to Mars office as a project or program manager. So we did something good there. So next, I want to also mention this OpenSpace is a collaboration between CCMC and American Natural History Museum in New York and Linköping University in Sweden, the computer science major students, like master's degree. So to really take the science outcome, the modeling result, turn into beautiful images, visualizations, and play them, display them at the planetarium all over the world. So this is like not only a good education tool, it's also a good tool to sell the science, what we do, and also inspire next generations. And here, if you go to this YouTube link, the Leila Mays did together with the master students from Linköping University, and they did a nice online kind of talk, educational talk regarding solar storms. So you kind of put this, you can see this beautiful visualization in a coherent story and learn something there, and appreciate the beauty too. So check it out. I think I'm going to stop here to answer the question. So next, this is extra one. I will also just want to mention that CCMC also work with, the Heliophysics Digital Resource Library to make the capability better. for both science and also space weather application purposes. So I'm done. Thanks.
Okay, excellent. Thank you very much, Yihua. It was a very interesting talk, and just to see the summary of how the CCMC has grown and developed and all the initiatives that are still happening. So we do have a question from the chat, and I also have one as well. Just in case folks need to drop off as well, I do want to mention to, of course, tune in next week on June 14. We're going to have David Jackson, and who's scheduled to present on space weather at the Met Office. So, okay, without further ado, jumping into the questions. So Vanya had asked, well, first of all, she said, very nice talk, and asked about the May 9th CME and wondered if it triggered SEP events by any chance?
Oh, the May 9th CME, no ICP, because the CME speed is not too fast, but it's a filament eruption, so it's kind of a higher density, higher magnetic field. So the magnetic field reached quite high at the in situ. At the ACE, like R1 location, ACE discovered location, it's like a 28 or close to 30 nanotesla. No ICP event for the May 9th. The ICP event is towards the end of the May. Yeah.
Okay, excellent. Thank you. And actually, and before I ask my question, I noticed someone had their hand up. Looks like Yari. Did you have a question, perhaps?
I have a comment. Thank you for the great talk. That was really nice. I just want to make sure that we have this comment there, like all the tools that you presented at the beginning that have to do with space weather analysis and real-time forecasting. Those tools are developed by CCMC, but then in real time they're used by the Moon to Mars Space Weather Office to do the real-time operations. So we're the ones that populate DONKI, the database. We're the ones that populate the CME scoreboards. And we're also the ones that do the analysis for the CMEs and run the real-time CME simulations. So in terms, we were, like Yihua said, CCMC is our parent. So we were the team that transitioned from CCMC, but since last summer to now, currently, if you have any questions about recent events, then the Moon to Mars Space Weather Analysis Office is the one doing the real-time operations. Just wanted to make that decision.
Yeah, thanks, Jackie. Yeah.
Sure. Yeah, thank you for that. Okay, cool. And actually, yeah, so just out of curiosity, Yihua, one question I had was thinking from the magnetic reconnection perspective, and I often look at MMS data, and I wonder with the scoreboard concepts that was just mentioned, so is there such a thing as like I don't know if it would make sense if it's a real-time measure, but like a scoreboard for day-side reconnection or night-side reconnection events, or maybe like when they're most probable? I'm not sure if you've had any efforts in that direction yet.
Not yet, but we definitely like to work on, such kind of capability. If there is a need, say, if you guys can provide the knowledge, like what's the trigger, like a potential condition, could be like a, sure. Yeah, the most probable, or kind of like a probability map or assessment. That'd be good. Exactly. Yeah. Yeah.
Okay. Very interesting.
Yeah. I mean the kind of the probability, or maybe the chance, is unlimited. I mean, we like to explore the community interest and reflect in the community interest in the future products or the tools.
Definitely. Okay, excellent. And so with that, yeah, I don't see any more questions in the chat. So let's see if there's one. Oh, maybe there's one more. So a comment from Pat. She was just saying, we do have real-time KP, AE, DST predictors if anyone would like to sign up for these real-time alerts. And she provided a link there in the chat. So anybody reading that, be sure to check out that link as well. So, yeah, okay, well, thank you very much again, Yihua. We really appreciate this. And this will be a great reference for the community to just to look back on and review what tools are available to the CCMC community. So,
yeah, all right.
Okay,
Thank you.
Thank you again. Hope everyone has a good week. So bye for now.
Bye.